Good morning, good afternoon, good evening, depending upon where you're joining us from. I'm Ira Feldman, the tinyML Foundation Managing Director, and I'd like to welcome you to our Pedestrian Detection Hackathon Awards ceremony. We're very happy to conclude the hackathon and announce the winners today, so thank you for joining us. And before we go much further, I'd like to thank all the tinyML strategic partners who make this and our other events possible through their generosity. If you have an opportunity to thank them, please do so. And we wouldn't be able to run the hackathon without judges with expertise in both the technology and the application. So I just want to take a moment to thank all the judges who have joined us during this hackathon and are on the call. We have Kwabena Aigim from OpenMV, Yu Kitamura from Sony, Jesse Mintz-Roth from the City of San Jose, Ho Nguyen from the City of San Jose, and Ravi Sivalingam from Qualcomm, and David Tischler from Edge Impulse. So I want to thank them all for their sharing their expertise and helping guide and judge this hackathon. So thank you. The next person I'd like to introduce is Mark Hansen, who is the head of marketing for Sony Semiconductor, who will give us the background on the hackathon.
Thank you, Ira. I wanted to also thank the tinyML Foundation, the San Jose Mayor, Matt Mahan, and his Vision Zero team, along with all the applicants who produce great approaches to using embedded vision AI in this pedestrian safety challenge. We're honored to be part of the tinyML Foundation. It's dedicated to developing a community of companies and technologies that are creating AI and machine learning enabled smart edge devices. These devices and solutions can actually enhance society and solve real problems, and they do it in environmentally friendly and cost-effective ways. Personally, as a longtime San Jose resident and a Sony San Jose employee, I was happy to see interest from the mayor's office to serve as a judge and subject matter expert to the new agile thinking around improving pedestrian safety that our applicants from around the world have submitted. Sony and the Adrius team have a long history of supporting the San Jose community and look forward to continuing to contribute our people, our technologies towards this effort.
The first team to present is Thunderbolt Faust. Diego Silva will be presenting.
My name is Diego Silva, and I'll be presenting here the solution of our team for the tinyML Pedestrian Hackathon of the Pedestrian Detection Challenge. Our Thunderbolt team is consisted by me, Ayan Chimirbay, Camille Zmaglova, Ahmed Al-Sheikh, Mohamed Fouda, and our advisor, Professor Ahmed Al-Tawil. We are part of the Communication and Computing Systems Lab from the King Abdullah University of Science and Technology. And as a background, we have first the focus here is to help the Vision Zero San Jose project, which aims to reduce the fatality on the traffic in the city of San Jose. And as you can see by this data, we had an increase of pedestrian fatalities on the last years. And the challenge of trying to solve it with tinyML on the edge is basically to provide solutions that can detect pedestrians in a way that it can capture data instead of images, providing accurate detections in compact systems with cost-effective solutions. And our solution is based on neuromorphic approach. Firstly, as our sensor, we are using event-based cameras, which are inspired on the functioning of the human eye. It has as a feature that it focuses on changes of brightness instead of absolute values, which can be seen here by an example where, for example, we have events and frames in this image, and the events focus only on the parts that are moving on the scene instead of the whole background like the frames. And like the human eye, it gives us some potentialities for high dynamic range, which means good view at night or during bright sun conditions. Here we have an example where we have events reconstructed and the equivalent frames, and we see that, for example, for the night scene, we have the events well, why the frames doesn't reconstruct it well, and we have a reconstruction of a bright scene from events. where we have a right sun scenario. It also has a good time resolution in terms of microseconds, good for high speed, power consumption in order of milliwatts. It also focuses only on shapes and features in general. It doesn't go for fine-grained details. Then it respects privacy as well. And in the examples we used, we achieved a 10 times lesser data rate. And the proposed detection system is made off of the following. First, for training our data, we analyzed the literature and we created a new data set combining two solutions that serve the best our purpose. And we also provided some synthetic data, which is even data converted from existing videos, and we trained it in general deep learning platforms, from where we highly recommend the use of Edge Impulse and MetaTF. And in our case, we adapted the YOLO V2 model to be running in an Akida device, which was a device responsible for the inference. It's also neuromorphic, has features, work well with sparsity. It also is low power consumption. And in the pipeline, you can see here, we connected the DVS sensor, live streaming data to our inference device, and we sent our result through the internet to a web interface. And you can see here in the bottom an example of such detections. And here we can see an example of our system working. We have here the same recordings for both frames and for events. And as I explained before, the events focus mostly on objects moving in the scene. Then you have we see the bicycles, the cars, the pedestrians, while in the frame you see the whole background being sent. A lot of data that's not useful for our purpose. And our inference speed is no more than 130 milliseconds, and the power consumption is bounded by 6 milliwatts, which is really low. And we can see here on the right, the same pedestrian being identified by events and by frames. And you can see here that our algorithm matches the purpose of identifying that is a pedestrian and where it is. And if you zoom in, we will not see any more detail about it. While the frame image, for example, if you zoom in, we can see more details about it, disrespecting the privacy of the person. Then it also achieved good terms in terms of privacy. And we can see here in terms of installation and bill of materials. First, we can see our prototype consisting of the brain chip, board, and the camera. And considering the price of the devices we used here, our prototype cost was around $7,000. However, thinking about production and deployment in the future, we can just go for the individual prices of the core items of each of those units. And when we analyze the price of the VS camera, Akida board, use of Edge Impulse, a monthly maintenance, we have a monthly cost, a total cost per unit of around $1,000, which has a big reduction. However, it's worth mentioning that both Akida devices and DVS cameras are at the beginning of their release, are new technologies. And it's a common trend in technology in general, especially for electronics, that the price tends to decrease towards the years, because at the beginning we need to compensate by the production costs, by the research costs. But as time passes and we can produce more units, we have a mass production, it's a general trend that these prices will be expected to reduce in the future. And I would like to thank to the organizers of the hackathon, the city of San Jose, and the tinyML Foundation. I would like to thank the BrainChip team for providing us a development kit and for providing training sessions, as well for Edge Impulse that provided access to their enterprise filters, and it was really useful for us during this project. Thank you very much.
Thank you, Diego. The next presentation will be Team Neurom. Christian Axing will present.
Thanks, Ira. Hi, everyone. Greetings from Nuremberg. Here's right now like a sneak preview in our work and our solution. So our solution is entitled Spider, and it has like a bit of work behind, made like by these four gentlemen here in the picture. And we're a team of students and faculty from Nuremberg Institute of Technology. And our solution to the challenge was like literally dictated by the very good energy footprint, robustness, and budget that such a solution has to have in order to comply with the Vision Zero goal. And well, what was our solution basically? We looked at biology. So we looked at how can we use low power neuromorphic hardware for both sensing and processing. And because BrainChip supported us with a really nice neuromorphic platform. We said, okay, let's give it a try and try to combine the benefits that biology has taught us into bringing technical systems. So basically, we looked at how retinas perceive, and we used this event-based camera combined with the neuromorphic chip, which processes natively the events from the camera, which is something new and something which has potential, especially when we want to develop at scale systems which react fast and have low power and efficient processing advantages. Well, our approach, the question is it fast enough? Well, as we see here on the two depicted panels, on the right side, you have a normal camera as ground truth. On the left side, you have the actual input that our system gets. So basically, instead of getting frames, you only get changes in luminance in the scene. And this is what our algorithm actually used to detect pedestrians and bikers in the road scenery. This approach, of course, has advantages in terms of energy efficiency, speed, and there's no redundancy because we only select relevant moving objects, which for our case are pedestrians and bikers, and it's privacy preserving. But like, is this solution accurate? Well, we actually fed the solution the event-based data you've seen, and we have a machine learning algorithm running behind which actually detects pedestrians and bikers based on their body structure using segments. So in principle, we just try to figure out to which body part, or is it a biker or a pedestrian, and how these events belong to their body, so that we can easily track as well those traffic participants in the scene using this efficient, non-redundant representation. Well, then we thought, okay, we have a system, but now, can we actually see if it's low power? Is it suitable for Vision Zero and the actual street use? Well, we actually went in the lab and measured the system while running. Instead of feeding live data on the street, because it didn't allow us to measure, we actually projected on a screen the same street scenario, and we measured on the same setup the power. So we got in the range of 4 to 7 watt for the camera plus neuromorphic system processing, basically this machine learning algorithm running in the background. So energy budget, energy footprint, pretty good. But then, is it ready for the streets? Well, we put our system in an oven, and we actually put the oven to 65 degrees, or this is basically what we tried out, and we actually put a running system inside to see if there's like, oh, will it take San Jose streets as well? Will it survive on the gantries? Well, it actually survived, and without any deterioration in the performance of the algorithm. And when it comes to cost, because I think Mayor Mahan, like, this is something which is really important for you, like, how much does it cost? Well, we've been doing our homework, and we thought at scale. Yeah, one more time, at scale is something we have to take a cut. And we came up with 2 solutions. So basically, the heavy lifting is done here by the sensor. It's such a it's such an interesting sensor, like so special. There are like many producers at the moment, but they all sell or say rugged versions. Well, what we came up with is 2 versions. So one is the best price, around $226 for the whole system, and the other one is around $3,000. But like, again, the difference is that the sensors are like, let's put it this way, are not weatherized, those which are like pretty cheap. But it'll take a lot of like, not so much money, but like take some budget just to make sure that these sensors are ready for the gantry. Yeah. And with this, I would like to end up the presentation, and thank you for all the judges and the sponsoring teams for allowing us to play with such interesting hardware. And of course, the challenge for us was a pleasure to take a part of it and actually be creative enough to come up with a $200 solution, which uses only 7 watt. Thank you.
Thank you, Christian. The last team to present is Leopard Imaging. Leon Liu will present.
Good morning, dear Mayor Mahan, dear judges, and dear other team members and audience. My name is Leon Liu, co-founder and CTO from Leopard Imaging. Thank you very much for giving me the opportunity to give you a very quick, brief introduction of our solution. First of all, I want to restate this problem and our motivation. People kill while walking increased a lot since 2009, from 4,000 to 6,000 more in 2019 over the nation. And we are very pleased to see that the city of San Jose already have take actions to reduce this problem. Our motivation actually is coming from this issue and our mission. Our mission is intelligent vision solutions for a better world. And we believe anything we do to make a better world with our technology, our knowledge, and our efforts will bring us happiness and business. And this is our solution. Our solution is based on Sony's Atreus Edge AI sensing platform. This platform, including several sensors and SDKs, and as well as cloud-based solution. As far as I know, the Sony's IMX500 is the world's first imaging sensor with built-in a neural network, which makes it low cost and high performance. So based on this platform, we developed the software, the firmware, the algorithm, the hardware to come up with a solution. On the right-hand side, you can see this block diagram of our camera. And this is a very powerful, yet low cost, low power camera will be mounted on the street light pole towarding the intersection. It's a embedded system, embedded camera, so it does everything from image capture, image processing, data analysis, get the result, and send it over to the cloud with very minimum data rate, because we are not sending constantly the video. So the result, we are talking about kilobytes per minute. With this data instantly to the cloud, the control center can see the data, so they know how many pedestrians, how many cars, and other things on the street in the intersection, so the city can take measures to mitigate the risks. Here's the highlight of our solution. So we use the state-of-the-art technology, YOLO V8 object detection model. We train it and fit it into Sony Atreus Edge AI platform. And the solution is low cost and low power. We are talking about at 1,000 units per unit with if we use a mesh network, it's only $300. And with the LTE and self-cleaning lens, it's about $600. And the power consumption is about 2 to 3 watts, low enough for using, for example, solar light or very minimum from the pole. And when we have this solution, we keep in mind it has to be low maintenance. So we include the following features: over-the-air diagnosis and updates, weatherproof design, especially we have a self-cleaning lens to clean up those water, dust, dirt from the lens to have a clean and sharp image all the time. Also, we develop a technology called adjustable regions of interest. You can see the yellow box with this high resolution and powerful sensor. If anything happened to the camera position, we don't need to climb up the pole to physically change it. We just over the air reassign the regions of interest. And this is really reduce the maintenance. And also we know that this will be a product using for years. So with our expertise and experience, we know that we can achieve this. Yeah, please allow me, give me a half minute to introduce Leopard Imaging. We are a company actually located in Fremont, very close to San Jose. We have 15 years of research and engineering expertise. We provide one-stop shop services, meaning we get the requirement from our customer and we do the feasibility study and discuss with customer, come up with a solution and design the hardware software system and do the validation and manufacturing all in-house. And we have manufacturing in USA in-house here and offshore. Again, thank you again. I would like to thank our team with their very hard work and smart work. I want to thank Sony to provide the evaluation kit and the SDK. I would like to thank tinyML Foundation and City of San Jose Vision Zero program to give us this opportunity to contribute to the community and make the world better. Okay, thank you.
Thank you, Leon. And let's go back to the mayor.
Wonderful. Thanks, Ira. And that was very impressive. Thank you all so much. I'm really thrilled to be here with you. And again, apologies for running a little late this morning. So if it's okay, I'll give just a few remarks I was going to give at the opening, a few thank yous, and a little bit about the purpose of our work together here and what it means to the city of San Jose, and I think many other people around the world ultimately. And then we can move on. Once Ira gives me the okay, we can move on to the awards. So I want to start by thanking tinyML and Ira for coming to us and really being willing to leverage their years of experience in designing and running hackathons for civic innovation, which created a very strong foundation for this process. It's helpful to have folks who have that kind of experience and have done this before. They've been a great partner. Also, huge thank you to Sony and Mark Hansen, who initially came to our office with an invitation to partner, and we're grateful for that outreach and Sony's commitment to democratizing access to cutting edge technology, of which Sony obviously creates so many incredible tools. I also want to thank our Department of Transportation staff. We have very capable folks here at the city of San Jose who work hard every day to serve our nearly 1 million residents. And I know they were key collaborators here, including Ho Win, Jesse Mintzroth, and Colin Hain. So really appreciate their work. And then you all may have had the opportunity to get to know Stephen Keynes, who's our Chief Innovation Officer and Budget Director in my office. Who has lent his expertise in public-private partnerships and is just all around one of the most capable and brilliant people I've ever met. So that was kind of the core team on our side who came together to organize and put on this hackathon. I want to thank the teams, you all, for lending us your creativity, your passion. You know, government does many things well, many foundational things that are critical. One area where we maybe aren't as well suited as the private sector is in experimentation and innovation and creativity and taking risks and being willing to fail fast to learn, and that highly iterative approach that our incredible technology sector and creative sectors bring to the table. So I'm a big believer in these kinds of partnerships, bringing in the expertise and creativity and innovation capacity of the private sector. We're very fortunate to be located here as the capital of Silicon Valley, right in the heart of Silicon Valley, with so many talented residents. But for this challenge, as you all know, we had teams competing from around the world, certainly the United States, but also Nigeria, Lebanon, Germany, and Saudi Arabia, a mixture of students, interns, and professionals from a very healthy mix of institutions. And I just want to sincerely thank you all for participating in this hackathon and putting in so much time and effort to help us come up to better solutions to a very significant challenge, not just in San Jose, but all over the country and frankly, all over the world. Just last year here, we had 65 individuals, 65 of our neighbors, brothers, sisters, mothers and fathers who died on our dangerous roadways, including a young child about the age of my daughter who died on his way walking to his local elementary school. Very heartbreaking for our entire city. So this has been something that we've really been working on from many different angles, and we know that technology and new technologies, new tools are going to be critical to changing this trend line we've seen in recent years. So with that, I'll turn it back to Ira to make sure I haven't missed any important thank yous or notes. And then if we're ready for the awards, we can move to that. But just want to express my gratitude on behalf of the city of San Jose. You all have been incredible partners, and I'm very impressed with the demos we just saw.
Thank you, Mayor. Let me just put the slide up for the award. Here are the awards, the award categories and the prizes, and then I will stop sharing and turn it back to you to announce them. 1 second.
Okay. All right, drum roll, please. So starting with our third place and a prize of $1,000, the award goes to Thunderbolt Kaust. So congratulations to the Thunderbolt Kaust.
Thank you very much.
Thank you. Thank you very much.
Thank you. Congratulations. On to second place. All right. Taking home a prize of $2,000, we have Team Neurome. Congratulations.
Thank you so much, Mayor. Excellent.
Congratulations.
Excellent job, team.
You did a fantastic job as well. And finally, of course, Leopard Imaging takes first place and a $3,000 prize for their solution. Well done, Leopard Imaging.
Thank you, Mayor. Thank you.
Very nice. Leon, did you want to say a few words?
Yes, I would like to thank everyone. Thank you, Mayor. Thank you, the judges. Thank you, tinyML Foundation and the city. Of course, thank our team members. Everyone's work hard, work smart, and their family to support the team. Actually, I have a little small request, if you could. If in the future, because we stay very close to San Jose. Actually, I fly the San Jose SJC every week.
Oh, great.
So, yes, I like the airport, very efficient, very fast. Yeah, and very clean. Yeah. And if in the future you have some time and Vision Zero group, they have some time, please come to our office and we'll give you more introduction of the company, our technology, and really we want to contribute more to the society. Thank you so much.
Great. We would love to get together, and I'll also note we have some office space right here in downtown San Jose if you're ever looking to expand. So we'd love to, love to welcome you this way as well. But yes, that would be great, and congratulations again. Now we do have one last award to present. So this was the Edge Impulse Award for the best use of the Edge Impulse platform in developing your solutions. And this award goes to Thunderbolt Koust. So congratulations. That's an additional $1,000 to the Thunderbolt Koust team. Congratulations and well done. And
Thank you very much.
Yes.
Thank you.
Yes.
Thank you very much, Mayor. It has been a pleasure to work on this hackathon, and we really appreciate the opportunity to contribute and to meet all these wonderful people at the same time.
Well, we've been thrilled to collaborate with you and really appreciate you putting in the effort. This is really meaningful work, and we certainly couldn't do it ourselves. So we're thrilled. Thank you. So I want to congratulate you all, our finalists. You've generated ideas. You've experimented and learned and kind of pushed the edge of what we're doing here, which is what this is all about. And I know that through future experimentation and collaboration, we're going to bring to scale, which is a term we all think a lot about. We'll bring to scale solutions that will ultimately save lives, which is what this is all about. So just thank you so much. And thanks again, Ira and tinyML, and of course, Mark and Sony for your partnership. You guys have been tremendous partners, and we're grateful for it. Thank you.
Thank you, Mayor Mahan.
Thank you, Mayor.
And I'd like to introduce Evgeny Gusov, the chair of the tinyML Foundation Board of Directors, who will have some closing remarks.
Hello, everyone. It's been a truly rewarding experience to be part of this amazing competition. And I wouldn't call it a competition. It was really a partnership of all people around the world passionate about using technology to solve real world problems. And I think as we mentioned many times today, pedestrian safety is a big issue. It's a growing issue, global issue. In fact, we've been asked by other cities in the world, like Milano, like, hey, can we do something similar too? And I think it's really great to see these teams coming together and proposing their solutions there. So congratulations to all the teams, all the participants. All the teams are winners, and we hope they will continue working solving this type of problems in their local communities as well. And tinyML Foundation is here to promote and enable this type of collaboration. We especially grateful to the city of San Jose and the mayor and his office for being innovative leaders in this space, for proposing Vision Zero program and really driving it locally, but also promoting it nationally and globally, especially now, because now it's the pedestrian safety month, and I think it's really great to see this leadership coming from the heart of the Silicon Valley. So I think we are extremely happy to participate with the city of San Jose and Sony and all the partner companies on this challenge, and really grateful for guiding us and for highlighting the problem statement, but also working with the team on these solutions. The judges were awesome. We had a very diverse team of judges to make sure that all the teams were evaluated carefully and provide the best decision there. And they were not only judges; they were mentors of the process. They helped the teams to guide them as well. I think this was really a true kind of team spirit, judges and teams working together on this hackathon. Sony, Mark and his team and Sony marketing team, they've been very instrumental in this challenge, from kind of driving it from the very beginning, but also being like great citizens and really offering their technology and their knowledge and their time to this important hackathon. I think we really look forward to continuing working with the city, with the community, with the whole global ecosystem of tinyML companies on driving this type of innovations forward into the practical space, and also working together on this private-public company partnerships together for new challenges. There are many challenges in the world, and we technologies are really passionate and charged to contribute with our innovations, with our technologies, with our products, with our knowledge. So it's really a great experience. And obviously, this hackathon and tinyML Foundation would not have been possible without support of our strategic partners. So those companies who are key members of the community. It's a very diverse ecosystem. It's a global ecosystem, companies from all over the world, big, small, software, hardware companies. That's what makes us strong. Executive partners are Qualcomm and Sentient. And then we have platinum strategic partners, Sony, who initiated this hackathon. We have gold strategic partners, Analog Devices, ARM, Edge Impulse, and Infineon, and Innoterra, Renaissance, and ST Microelectronics. Synaptics, and we have a list of silver strategic partner, which is also growing. Again, thank you again. It's been a great experience to see this energy, this passion, and these solutions, and we look forward to continuing hackathons and projects for good.
Thank you, everyone. Thank you for joining us. Thank you for participating, and we wish everybody a good rest of their day. Thank you.